Hello, welcome to today's lesson. So today we are going to calculate for the figure below. We have to calculate for the circuit resistance, total current, power in each resistor, voltage in each resistor, and then the total power. So that is the circuit. So the circuit is having resistor R1 and then resistor R2 connected in parallel across 20 volts power supply. Okay, so before we start with the solution, I want you to take note of this. So since it's a parallel circuit, the voltage is common. Okay, so the supply voltage will be the same voltage across resistor R2 and it will be the same voltage across resistor R1. Okay, so when you are dealing with a parallel circuit or a parallel network, the voltage is always common. Okay, I want you to take note of this before we start with the solution. Okay, so let's move on with the solution. So solution I, we have to calculate for what? The total resistance, that is RT, okay, total resistance or the equivalent resistance, okay. All right, so we are going to use the formula R1 times R2 over R1 plus R2. We call it the product over sum. All right, so this is equal to 5 times 10 over 5 plus 10. And that is going to be what? 3.33 ohms. So the equivalent resistance or the total resistance is equal to 3.33 ohms. Okay, so let's move on with the second one, that is II. And we are to calculate for the total current. So IT, which is the total current, this is equal to what? VT over RT. By Ohm's law, current is proportional to the supply voltage and inversely proportional to resistance. Okay, so IT is equal to what? VT over RT. So VT is the supply voltage, RT is the equivalent resistance or the total resistance. Okay, so from the circuit, the supply voltage or VT is what? 20 volts, and the equivalent resistance or the total resistance is equal to what? 3.33 ohms. So this is equal to what? 20 over 3.33, which is equal to what? 6 amps. So the total current or the supply current is equal to what? 6 amps. I hope you understand. So let's move on with the third one, that is III. And we have to calculate for the power in each resistor. Okay, so P1, that is the power across resistor R1, is equal to what? V square over R1, and this is equal to what? 20 square over 5, and that is going to give us what? 80 watts. And then P2 is equal to what? V square over R2, and that is 20 square over 10, which is also going to give us what? 40 watts. So P1, that is the power across R1, is what? 80 watts, and then P2, that is the power across R2, is also what? 40 watts. I hope you are following the calculations. So let's move on to the fourth one, that is IV, and we have to calculate for the voltage in each resistor. Voltage in each resistor. So I explained earlier that when you are dealing with a parallel circuit, the voltage is always common. Okay, so 20 volts, that is the supply voltage, will be the same voltage across resistor R2, and it will be the same voltage across resistor R1. So the supply voltage VT is equal to V1 is equal to V2. Okay, V1 is the voltage across R1, and V2 is the voltage across R2. So VT is equal to V1 is equal to V2, which is equal to what? 20 volts. I hope you understand. So let's move on with the last one, which is V, and we have to calculate for the total power. So PT, which is the total power, is equal to what? IV. I is the supply current or the total current, and then V is the supply voltage or the total voltage. So when you multiply the supply current by the supply voltage, we are going to get what? The total power. Okay, so we have 6 times 20, and that is going to give us what? 120 watts. So the total power is what? 120 watts. I hope you understand. Thank you so much for watching the video, and please make sure you subscribe to the channel. Okay, make sure you subscribe to the channel. Thank you.